Hi, everybody. My name is Atefeh Mohajeri. I'm from the AI Research Lab at Nokie Bell Labs. It's a pleasure to be here today and to present to you our cutting-edge research where we apply AI to the challenges of the future. At Nokia, we create technologies that are improving people's lives and driving sustainability. Nokie Bell Labs is Nokia's global research arm where we are focusing on the future of technology. That includes research in network fundamentals like 6G, next generation of automation, and of course, AI. We see AI as being at the center of all the technology challenges shaping the future. So, what kind of research we are doing around AI? We have three main areas of focus. First, AI fundamentals, where we are developing next-generation algorithms, language models, and computer models. Second, AI in communication networks. We are applying AI to wireless and other kind of networks across the life cycle of the network, from design to maintenance and customer care. And third, AI for industrial automation, where we are focusing on AI solutions that are fueling Industry 5.0 by optimizing digital technologies and digital twins. Today, I'll be presenting one of our AI research projects where we are using AI to create synchronized digital copies of physical worlds. This dynamic digital twin technology can add value to many businesses. For example, let's say your business uses warehouses for your product, or you are a sports fan. Probably you are thinking now, what do these two things have in common? Well, our dynamic digital twin solution can help you reduce your operation costs in the warehouse, or revolutionize the way you view your favorite sport game. And let me explain how. Now that industrial metaverse is going from an idea to reality, tools are emerging that are allowing us to digitally monitor what is going on in public or industrial spaces. For example, consider a warehouse where inventory is changing constantly, and you want to have real-time control and monitoring of the warehouse, and you want to be able to do it remotely. Well, how can you do it? Our solution is based on a dynamic digital twin that provides a comprehensive understanding of ongoing changes. Another example of a changing environment is a sport arena. Let's say you want to be able to transition smoothly from one camera view to another camera view in a game, in a hockey game, for example. Or you want to view the game from a specific seat in the stand. Or you even want to view, let's say you even want to view the game from right on the ice, where it's usually hard to get a good view with a camera. Well, with our dynamic digital twin, all of this is possible. Okay, now let me tell you a little bit more about it and say where the AI is in all of this. So the main question we aim to answer is the following. How can we create a 3D model of an entire space where we have access to very limited camera views? We accomplish this by using a collection of revolutionary techniques called radiance fields. And neural radiance field specifically is an example of radiance field technology, where the idea is you start with a small set of images, their corresponding camera poses, and train a neural network to represent your scene. Then, using this trained model, you are able to render images from arbitrary angles, even the views that you haven't seen with your camera while you were capturing the scene. Our dynamic digital twin solution transforms this NERF static model to a dynamic representation where real-time updates are possible and you can view changes as they are happening. Now let's go back to the warehouse example. In order to create a dynamic model in order to first collect the images that we need to create a model from the warehouse, we fly a drone in a warehouse with a camera on board and capture a small set of images. Here you can see a model, a static model that we have created from a warehouse. Then the question is, how can we dynamically update this model with the incoming inventory? Well, we can fly a drone in the warehouse every night and capture new inventory, as you saw in the video. Here is a first-person view of what the drone sees, actually. So to put everything together, we start by creating a model from empty shelves in the warehouse. Then we create photorealistic 3D models of everything the drone sees and captures and render them in the NERF model. Our solution also allows for overlay of the product's information in the model. Can you imagine the experience of having access to this up-to-date, augmented digital copy of your facility that allows you to control and monitor the warehouse from right on a tablet, rather than going and doing a physical, spending the time to do a physical check? This can help you reduce the cost of your operation, improve the accuracy of inventory management, and minimize risks while increasing safety. Now let's talk about the 3D models of a sports arena. Usually in a sports arena or a stadium, cameras are installed in fixed position. That really restricts the angles from which spectators can view the game. As I mentioned before, our solution is built on NERF, but a standard NERF can only represent a static scene. So for example, here you see a NERF that we have created from a hockey arena that Nokia owns in Finland. So how can we dynamically update the hockey actions in this model? We can do so by taking the feeds from different camera views, segment out the players, and then render them in the NERF. Here you see the feeds from different camera views in the hockey arena. Here you see the segmentation of the players. And finally, this is the rendering in the NERF. This is a view from an arbitrary seat in the stand. Here, we can fly from one camera view to another one. And here is the view from right on the ice. So you can imagine like your new and exciting experience once this technology is deployed. So I hope that you like this presentation about our dynamic digital twin technology. I'd like to invite you to come and visit us at booth 116. You can also use this QR code to find out more about our project.